Significant figures. This often causes more headaches than it needs to. One thing to remember is that your significant figures must go to the same place value as your uncertainty. So if your uncertainty goes to 3 place values after the decimal point, then your actual number also has to go to the same number of place values. Significant figures in conversions are considered infinitely precise unless it's molar mass, because you choose which decimal place to use. In that case, then use the same number of sig figs as your given value. And your sig figs are usually, significant figures, are the same as your given value. So if your given value is 3.63, so that's 3 significant figures, make sure that your molar mass from your periodic table, you choose to go for 3 significant figures, and that your answer will then have 3 significant figures. Remember that 1 mole has infinite precision. There's no doubt that we're talking about 1 mole. Similarly, things like 60 seconds in a minute, that's infinite precision, and even though the number looks like there's only 1 significant figure, it actually doesn't affect anything. So by and large, you are going to go by your given value. So if your given value has 3 significant figures, your answer should have 3 significant figures. So what is a significant figure? The rules are that all non-zero numbers are significant, and any zeros that are flanked or surrounded by non-zero numbers like this are also significant. So then the question is, what happens with zeros? So zeros after decimal point are significant if they're preceded by a non-zero number. So no, because it's not preceded, it's not following a non-zero number, it's in front of a non-zero number. So this only has 1 significant figure. This has 4 because they're being flanked. This has 4 because it's following a non-zero number. They are preceded by a non-zero number. And this 0 will be no, but these zeros would be yes, so this would be 3 significant figures. This 0 is really only there to show you that the point is there, so that you can see the decimal point and it doesn't get lost. So you think it's 0.2, not 200. If there's a decimal point, all the zeros are significant before. So 3,000, there's no decimal point, 1 significant figure. 3,000 point, yes, it's significant, so there's 4 significant figures. It's just so much easier when you use scientific notation, so like yay scientific notation. In scientific notation, every number in front of the times 10 to the whatever are significant. So if I write it down as 3 times 10 to the third, it's 1 significant figure. However, if I write it down as 3.000 times 10 to the third, that would be 4 significant figures. When you are multiplying and dividing, your answer will have the least number of significant figures. And when you're adding and subtracting, it goes by place value. But we're going to be multiplying and dividing, so that's going to be usually the rule that we're going to follow. So again, use the given value in your word problem or the given value that you have in your lab data, and then go by that because it's so much easier that way.